Oh, hey, Skip.
Oh, what's up, Mr. Hananana?
I'm fine. How are you?
I'm good. How's it going?
Everything's fine. You know we're having a field trip today?
Oh, really? Where?
We're going to a dig site. So what do you think we're going to be learning there?
Well, what is there at a dig site? There's dirt, there's bones. So I'm just guessing skeletal system.
Yeah, skeletal system. You're right.
Sweet.
Yeah. Let's go. The bus is waiting for us.
Word.
Hey, Skip. We're going to the dig site. So I'm going to ask you a couple questions to see if you know about the skeletal system. Okay? Do you know what the 5 functions of the skeletal system are?
Indeed I do, sir. They are support, storage, blood cell production, protection, and leverage.
That's good. You got all 5 correct. Okay. Now, let's start with support. How do you think support works? And be brief.
Alright, well, support works that basically if we didn't have the bones, we'd be blobs.
Yeah, it would. How, though?
Well, muscles attached to our bones, which allows us to move. And if we didn't have the bones, then again.
Yeah, we'd be moving. We wouldn't be standing up straight. Do you remember the 2 A's of the skeletal system?
The appendicular skeleton and the axial skeleton.
System. Right. What does the appendicular system form?
Your legs and shit.
Your limbs. You're right. And without the appendicular skeletal system, we wouldn't be able to move. And what does the axial skeletal system form?
Just the rest of your body.
The rest of the bones in your body, which allow you to
continue moving.
Not continue moving.
You're the teacher, man. Like,
not continue moving, but to stay standing straight.
Okay.
To maintain the homeostasis form. All right. Now that we're finished with support, what about storage? How do you think storage in the system is important?
Well, I know that there's a lot of nutrients stored in bones. Also, there's yellow marrow, there's the yellow and red bone marrow supported, but that's in cell production. But basically, there are nutrients stored in bones, and so bones act as a reservoir in case certain situations where you don't have those nutrients, where you're depleted of them, and so they act as a supplement.
Also, yellow bone marrow allows us to store fats and become red bone marrow, which brings us to our third function, which is blood cell production. How does blood cell production work in the skeletal system?
Well, basically, the red bone marrow and all that stuff is stored in a cavity within the bone, and so from there, blood cells are produced, and then they're split into whatever category needed. It may be just red blood cells or white blood cells.
Yeah, that's correct. Which now we have the 4th function, which is leverage. And leverage allows us to walk, like you said earlier, and move our skeletal system. Also, we have the last one, which was what?
Leverage? Protection.
Protection. And how do you think the skeletal system protects us?
Well, I mean, bone's made out of, if not the strongest material in the human body.
Actually, stronger than steel.
Okay.
It's very strong.
And so this helps us protect ourselves from anything, in an everyday environment. Maybe animals or just a car crash. And so for example, we have these things called ribs, which protect our inner organs. Which
protect our main component of our cardiovascular system, which is our heart, which is inside there, and also our respiratory system, which is our lungs and even our esophagus and trachea, which are over here, and our larynx, and all very important things inside of our gastrointestinal system, as well as our respiratory system.
Yeah.
Yeah.
Whoa, Mr. Hana, look what I found.
That is cool. You found a long bone.
Whoa.
Do you remember this from class? Can you name all the parts of a long bone?
Oh yeah, I can. In fact, I have this diagram. It shows all the parts to a long bone.
That is so cool.
At both bottom ends of the bone is the epiphysis, and this is where the spongy bone is located. And in between spongy bone, there's an epiphyseal line. Obviously, the top epiphysis would be the proximal, and the bottom the distal. Surrounding the entire bone is the periosteum, which is a thin fibrous layer, and the middle part of the bone would be called a diaphysis. In the diaphysis, there's a medullary cavity which holds yellow and red bone marrow.
That is correct, Skip.
So,
You did
Mr.
very
Hana,
well.
could you tell me anything about the tissue level of bone?
Actually, I have, and I also have a neat diagram for it as well. Over here, I'm showing the tissue level of a bone. Over here is the spongy bone, which is made up of these curls of bone that's hard. It's used to hold the marrow as well as absorb impact when damage comes to it. Over here is the compact bone, which is made of these little ring-like things that are called osteocytes. And in the center of each osteocyte is something called the Haversian canal. These Haversian canals contain the perforatory arteries and the perforatory veins, which supply blood to all these cells. And over here in this diagram as well shows the periosteum.
Could you tell me the difference between osteoblasts and osteoclasts?
Osteoblasts are used to create more of these layers of the osteocytes, osteons. Osteoclasts destroy these layers.
Okay. Is there any reason for destroying them?
So that it can allow for bone growth, and so that it can also create new osteons that are stronger, more durable than the last generation.
Sweet.
Yay.
Alright, well, hey guys, after we went to the dig site, we found a lot of bones. These are just diagrams of some of them. So as you can see here, we found the clavicle, some ribs, and sternum. And these are all flat bones. And as you can see here, you know, they perfectly, you know, line together, and this is the xiphoid process, right? And here we found a spinal cord, and it's divided into 5 sections: the cervical section, thoracic, lumbar, sacrum, and coccyx. And the spinal cord is composed of irregular bones, as you can see here. And that's pretty much it for these bones.
Also at the dig site, the students found a skull. The skull is made up of several parts, and we were able to identify them using the fissures inside the skull. We were able to find the parietal bone, the temporal bone, the maxilla bone, the mandible, the nasal bone, and the frontal bone. These sutures, as they're called, were once fontanelles in babies, and the fontanelles then became these sutures which separate these bones from other parts of the skull. Fontanelles are used to kind of allow the baby to come out of the head, so it's more come out of the mother.
Vagina?
So, yeah, so that it's more so that it's more their head is more flexible. There are several types of movable joints in the skeletal system. The first movable joint is the gliding joint. The gliding joint acts as sort of like 2 planes on top of each other, sort of glide on top of each other. They allow movement across only one plane. The second type of movement is the hinge joint, which is an example of this would be between the humerus and the ulna. This allows movement across one plane as well, and it allows for movement to go like this between the radius and the between the ulna and the humerus.
Superflexion?
Yes, like this.
Okay.
Also, there is a pivot joint, which is on your vertebrae, and this kind of movement allows it to rotation around, and examples of this would be your vertebrae, of course. Another type of joint would be a ellipsoidal joint. An example would this between the radius and the ulna and the carpals in the hand. It allows for movement to be in multiple planes, like this and like this. It allows for movement to be in like 360 directions. The other type of joint is the saddle joint, and the saddle joint, an example between this would be the metacarpal of the thumbs, and this allows for movement as such, like so, the flexion of the fingers. And the last type of joint is the ball and socket joint, which is of course your shoulders, and this allows for a wide range of movements in all types of directions.